today we are going to start with a very important chapter of the set theory. We already have finished set theory. So we are going to start with relation and functions. We are going to start with relation and function. This is one of the very important topic. This very important topic of, I can say, Z, IIT Z, right? Relation and functions. Under this topic, what exactly we are going to study? First, let us go for depth, and then we will start with one by one. First, we are going to start with Cartesian product of sets, what it is. Then we'll start with relation on a sets A to B. Then relation on a set, single set, that means A to A. Then types of relations. Then functions, and then lot of questions. And in between, we'll have to see some mathematical tools which will be helpful for working out for a domain and a range of the set. So without much delay, we are going to start with the relation and functions. The very first thing is Cartesian product of sets. Cartesian product of sets. Right. So I type the heading here. Cartesian product. So Cartesian product we are going to start with. But before Cartesian product, we have to know one more thing, something called order pair. Order pair. Something called order pair. Something called order pair. Now, what exactly is order pair? Now, what exactly is order pair? Order pairs, as name suggests you, order pairs means something which has a direction, right? A fixed order, right? Just I want to start with one quick example so that we can understand this, and then we'll proceed for the formal definitions. Say I want to consider two different sets, collections, two different collections I want to consider here, right? I want to consider two different collections. One of the collection name I have given A, and then the another I want to give name B. These are the names we want to assign. These are the names we want to assign. And then here, what I want to say that I want to write some name. Say Ram, one name. Why I am writing, we will come to know afterwards. Sham, right? And then suppose someone called Hari. This is one. And here I want to say that these are the items what they like. Say samosa. Some items I want to keep in B. Samosa. And then say barfi, right? And then say sweet. Okay, it is not necessary that both the collections should have same number of objects. It is not at all necessary, right? Now I have to collect the data. I have to collect the data. Data is about what? Who likes what, right? Who likes what? This is the data I want to collect. Suppose this is a survey I want to collect. So for that, what I'll do, I'm going to make a system. The system is that I'll write a bracket and I'll fix two places. The first place I'll reserve for the name of the person, and the second place I reserve for the person, reserve for the items which is like by that particular person. Say, before that, I would like to also see how to connect who likes what, how to connect it, right? So for that, I'll be using arrowheads. Say Ram is liking Barfi and Hari is also liking Barfi. Probably it can be happening. And even Ram can like other items as samosa. Sham doesn't like anything, right? So this may be the case. This may be the case. Now, if suppose I want to express this whole thing not in the figure but in some writing, then what will do? I'll take the name of the person Ram and the items. Both the items will not be written at a time, one by one by one. Samosa. Then again I can write Ram because Ram has two options. One is Barfi. Then Sham there is nothing, so I'll not write any information for him. So Hari and Barfi. So we have got some of the pairs. Now this pair is known as ordered pair. Ordered pair because I have already fixed that the first place is preserved for the person and this is for the items. Right? In no case you will extend this. Right? Tomorrow if instead of 3 persons I take 10 persons in except sorry in instead of these three objects I take 10 objects, 12 objects or many objects, my this particular order will remain same. So because of that, these kind of things are said to be ordered pair. So I am clear about this particular observations, right? So this is the idea of ordered pair. So you be very clear about the ordered pair concept. So I'm going to the next part. Now we are going to define what is Cartesian product very clearly, right? Cartesian product, Cartesian product of two sets, first two sets. Say then for any two non-empty sets, what we do, Cartesian product is defined like this. Ordered pair AB, where we pick A from the capital set A and this is the capital set B. Right? So this is an ordered pair. We mentioned it ordered pair means A cross B means it is very necessary. It is very necessary that you pick elements of A and you put it in the first place, pick elements of B and you put it in the second place. There is no way out. There is no way out, right? This order pair you have to maintain. Then we call this as the Cartesian product, right? Of set A and B. And here for definition, we consider this to be non-empty. It is not necessary that always it should be non-empty. We'll be getting options for that. Now presently we are considering non-empty, right? So now just a quick example I want to take so that you can understand this. Say A is the set containing 1 and 2 and B is the set containing element A and B. Then what is A cross B equals? A cross B will be equal to what? I first pick the elements of the set A, 1, and then I try to make a pair of 1 with A and B, all possible. Remember it. 1 comma A, 1 comma B. And then once you finish with A, do the same thing for 2. So this is A cross B. Right? Similarly, if somebody asks you what is B cross A, so it will be what? This time we'll pick the elements of set B first and then we'll do this. Right? Till here, I do hope that you have understood. There is no doubt about that. There is no doubt, I think. Okay. So now, this is example number 1. Let us go for one more example in bigger set to observe something. Say A is equal to 1 comma 2 comma 3 and B is equal to say minus 1 comma 2 comma 3. It is not the case that we cannot have anything in common between A and B. It can be, right? So now I can find A cross B. Acha, one more thing you should notice. It is a chance that I have written three elements in both the sets. It is not necessary that you should have equal number of elements in both the sets. Right? Like here I have taken 3 elements, here also 3 elements. Doesn't mean that always equal number of items should be there in each of the sets. It is not like that at all. Okay. So now once I try to construct A cross B, I'll take one from the first set and I'll try to construct all the possible pairs with one of these 3 elements, right? 3 pairs will be possible. So it will be 1 comma minus 1, then 1 comma 2, and then 1 comma 3. Then once I finish with 1, then I'll start making the order pairs with 2, right? This one, sorry, this will be 2. And then this will be 3 after once we finish it. Then just 3 comma minus 1, 3 comma 2, and then last is 3 comma 3. So that's it. That is the order pairs, right? So now, before we proceed further, we will be having a very important observation here. That observation is very, very important. You should note it. What is the important observation we get? You try to see. The important observation is that number of elements in A cross B is number of elements in A into number of elements in B. Remember it, we talk about the distinct elements. If any repetition is there, we should not consider it. So this is what the observation is, but how it comes, right? How it comes. I pick the example, this example I want to take, right? This example I want to take. I just want to take the example from here. Let us try to get what exactly it tells you, right? I'll be explaining this to you. See, what we have, set A contains how many elements? How many elements we had? Two elements. One is 1 and another is 2. Once we picked up 1, then I have to relate this 1 with the elements of B. So as B has two elements, one will be related to A once, another time it will be related to B once. That means I am going to get two ordered pairs against one. Why? Because there are two options open from the set B. So if I have one element in the first set, I have two options open. If that same set, that is the first set A contains one more element, then I'll be open for two more. If there would be any more, then I'll be open for two more. Means for every element in A, I am open for two options. So as the first set contains two elements, for every two elements, there will be two options open. That gives me 4, right? And if I generalize this, considering that n of A has m number of elements and n of B has m number of n number of elements, then each m will be having n number of ordered pairs. So total number of ordered pairs will be m by n, and that's generalized this particular form. Okay, so if you have finished, you indicate me. We'll go to the next. Okay, then I'll go to the next board. Now in the next board, and the next board you see, it's not that we define only the Cartesian product for two sets. We may be generalizing it for three sets or more than three sets, right? So if we are talking about three, then we get here ordered triplets, right? This will be taken from B, this will be taken from C. Similarly, if suppose I want to define this, that there are n number of sets. So what we get? Here we get ordered n tuple. We call it n tuple. I'll write that word. It is an, and each of the ai has been collected from I, and I is ranging from what to what? 1 to up to n, right? 1 to up to n. So this particular thing is called n tuple, n tuple, right? Or an uh, ordered n tuple, right? So this you can write. So this is the way how you can generalize. And in the same way, the formula can be also generalized. What is the formula? Number of A1 element in A1 cross A2 cross AN. This will be simply number of element in A1 into number of element into A2 into number of element into A3 and number of element in an. Now just try to see one of the very, very important part. Do not get confused with this signs, right? This is not multiplication which you do in arithmetic. This is the multiplication which represents the Cartesian product, right? This doesn't show any numerical multiplications. But here, these are the multiplication sign. What I use dots. These are arithmetical multiplications, multiplication of numbers. So be very, very alert about these particular cases, right? So after that, we have a notation for this. Instead of writing this bigger A1, A2, AI, etc., we can sum up or we can shorten this, right? By writing a symbol. This is this is a pi, capital Pi. I goes from 1 to n, and we write AI, right? Or some authors used to write capital X. X matlab multiplication sign. I goes from 1 to n. This is AI. So these both, right? These both are related to the. These both are related to the representation of this particular product of n number of sets. Please see this, and if you will be having any questions, any queries, you can ask me. Okay, I do hope you do not have any queries for this. So I'll go for the next one. Next one, right? So now, what exactly we'll get in the next one? You see, now we'll be talking about A cross A. What is the difference between A cross A and A cross B? Yes, there is very less difference. This time also we'll be taking ordered pair only, but this time difference is what? We are picking both the elements from the set A itself, from the set itself. Similarly, if somebody asks you that it is A cross A, then it is the ordered triplet where elements are taken, all the elements are A, B, C, and this all are taken from the set A, same set. Similarly, if I get these for n number of times, n times, then this will be giving you what? Ordered, again ordered n tuple. Say A, B, C, D, last what I like. Some letter Z I write. Right. I should not write some letter Z. It is n times. Then these all A, B, C, D, etc. These are belonging to the set. Right. So this is the way how we write. Now we have alternative options also. Sometimes you may be getting this can be written as A square, this can be written as A cube, this can be written as A to the power n according to the number of sets. Right. So this you must be very, very clear about. Right. So after that, what will happen? You see, in case of number of elements, n of A cross A should have been n of A into this is the okay. I use a dot. So this gives you what? N of A square is equal to n of A whole square, right? So this is one of the very important part. Similarly, if we generalize, n of A cube will be equal to n of A whole to the power 3. So in this way, if we proceed, n of A to the power n will be equal to what? It is n of A to the power yes, right? So this is the general one which we need to remember, right? So please observe that. And if you have any questions, any queries so far, you can ask me. I'll pick up some problems now so that you'll be able to understand.
Sir,
Yes,
sir, the n of the Cartesian product is non-multiplication, right?
yes,
Sir, so can we write? You wrote it as n of A cross A is equal to n of implies that n of A squared.
yes. That is a symbolization which we have accepted, right? That is, you are talking about this perhaps. As this is not multiplication, how we can write is like this. Is it the question you are asking me?
Yes, sir.
So this is actually convention. We have made this convention just to make us easier or make us comfortable with the expressions, right? That means what I want to say is that you see, if you have two different sets, you will never write this as AB. This will not be right. AB will be something else. What it will be meaning here, I also don't know because never we got such sets or such type of symbols. So A cross B means A cross B only. But whenever the sets are same, we can write it like this. This is a convention to us. Any more thing?
No, sir.
Yes.
No, sir. No more
Okay.
doubts.
Okay. Then you come to the note. I'll be taking some questions now. Before that note, very important note. If A is phi or B is phi, then we consider this to be phi, cross product, right? Cartesian product to be phi. We consider this. This is one of the important points. And if A or B is infinite, right? Then we consider here also in this case this as infinite, and we will not be able to find it properly. That is one of the very important note you have to remember, right? And in third note, always remember these things. It can be of course analytically proved that if in case you get A cross B and B cross A both equal, then this will imply A equal to B and in the reverse direction also. So this is one of the very important result. It seems to be very small, but it is very important. It seems to be very small, but it is very important. Right? I'll be picking up some questions very shortly. So you just see whether you have any questions to, or queries to ask. No, I think so. I'll start with questions, right? I'll start with questions. Some of the important and small questions first to warm up, right? We have to warm up first. Then we'll be able to go for bigger questions. Okay. Question number one, suppose. If A equal to A comma A, find A cross A, number one, and you find A cross A cross A. So this you have to find. This you have to find. Now solution. Simple. If I write this for my convenience, both the sets, if I write like this, then it will be easy for me to form this A cross A. So how we do it? How we do it, you see. How we do it? I first fix this element in the first place of the order pairs. And then all possible order pairs I make with this. So it will be AA, then AB. Then once I do these two, then I'll be thinking about the other, which B. So it will be B comma A and it is B comma B. So I'm done with this, right? I'm done with this. Now I'm going to do for 3 A cross A cross A. Now before I do the correct one, I want to show you one thing which is wrong. And many times students do that, right? The wrong thing first I want to do. It is the wrong thing. What I'm going to do is make sure. What they do is like this. Because they have already found A cross A, they write here the elements like this, right? And with them, they write A cross B. And after that, they are writing this is paired with this A. So A comma A comma A. then A comma B, then this second one will come A comma B comma A, and then A comma B comma B, etc. I'm not completing this. So likewise, they will be getting the ordered pairs. So they will be getting total eight pairs. That will be correct. Eight number of ordered pairs. Ordered triplet they will get. So now just before I go for the explanation from my side, can you find anything wrong here? What I explained. As I told you already that this is wrong only. But now can you identify anything wrong from your point of observation?
No, sir.
You did not find anything wrong, right? So let me explain this. Let me explain this. This is very important to observe. Anyway, that's not an issue that you did not find wrong, but this is wrong. What is the mistake you see? Once I am asking you to find the ordered pairs, sorry, product of this set with this set, I need to pick one element of this, and shape of the element of this is not a comma a, but a comma a in the bracket. So once I make a ordered pair of this set with A, so my ordered pairs ultimately coming out should be looking like this. Bracket, in bracket A comma A, then comma A. It would have been correct if I followed this procedure. But first of all, this cannot be written in this way. That is first mistake. Second mistake, once you write like this, then you cannot write it. Right? But one thing is very sure that if you do everything this in the rough without showing anyone to get the possible connections of the order pairs, this is a good way. This is a good way. That means when you write the answer, you write the answer directly like this. A comma A comma A. Do not show invert this step. This will be wrong. So you write it like this. And you go on completing all the possible order pairs like this, right? So should I complete this? I think I should not complete. You'll be able to do it. In fact, by the time I am speaking anything, I have already completed six pairs, two more are there. Right? So that will be right. And then you will complete this. Right. So this I think you'll be able to complete. Please check and then you let me know if you have any question.
No, sir.
Okay, then I'll proceed further with the next board. Now question number two. Question number two. I want to pick a question number two. If 1 comma 2, 2 comma 3, and say 3 comma 1 are three elements in A cross B, and number of elements in A is 3, number of elements in B is 2, then number 1, find A cross B, number 2, find number of elements in A cross B, then find B cross A. So these are the things you have to find. Suppose. Right. Please note down the question quickly as possible. I'm drawing this line so that I can resolve the area.
None, sir.
Okay. So now we'll be going for the solution of this. Okay. First of all, I'm giving you the complete. process solution so that if you write it in the descriptive exam also you will get it. We have n of a equal to 3 and n of b equal to 2. Now 1 comma 2 belonging to a cross b definitely would imply what? 1 belongs to a and 2 belongs to b. 2 comma 3 belongs to a cross b implies 2 belongs to a and 3 belongs to b. And then last 3 comma 1 belongs to a cross b implies 3 belongs to a and 1 belongs to b. Sorry, one mistake I did. You make it to third order, last order pair. You make it 3 comma 2. So this 2. So now once you have finished with this, now you can write what are the elements you got in A. You got these three elements in A. So that is 1 comma 2 comma 3 distinct element, and B what you got, that is 2 comma 3 comma 2 again. So 2 you should not write. This is considered as 2. So now these are complying with these particular things now. This n of A equal to 3 already we got, and here n of B equal to 2. So we are complying with the requirement. So these are our sets. A and B has been determined. This is the first part. This is the first part. Number two is what? N of A cross B. Now it is directly possible. 3 times 2, that is 6. Right? Okay, I haven't asked in the question. Find A cross B. I have written. It is A comma B. Sorry, not A cross B. Find A and B, and then number of elements in this, and then find B cross A. Number 3. What is B cross A then? Then you take the elements of B first. That is, set B, I am having 2. So all these ordered pairs with 2 should be completed. Right? And then you should complete the ordered pairs with 3. Right? So whatever you get, this is B cross A. So you are done with this. Please see this. Okay. So we'll be going for another problem. This problem will be for you. You'll do it as a homework, home task. Question number 3 perhaps. Right? If A equal to 1, 2, 3, 4, 5, 6, B equal to set AB such that A, B are belonging to A, right? And A divides B. So you have to find what is B. What is B you have to find, right? This time we are getting not directly the order pairs, we are giving you conditions. These two will be written as an order pair if A divides B. Just I'm initiating you, right? So you can see here A divides B, and remember these elements should be taken both from A only. So let me keep the value of A as 1 at the beginning, and then I look for the possible option of B. If A is 1, as you know, 1 divides every element. So B can be taking all these possibilities, right? B can be taking all these possibilities. There is no problem at all, right? So in that case, all these ordered pairs will belong 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, and 1 comma 6. All these will belong to your record set B. But apart from this, now you fix with 2. 2 will divide 2 out of those numbers. And what else? 2 will divide 4, and 2 will divide 6. So these are the order pairs. Then you start with 3. 3 will divide 3, and 3 will divide only 6 out of those. And then now, once you finish with 3, you take 4. 4 will divide only 4, nothing else. 5, if you take 5, will divide only 5. Then 6 will divide only 6. So these are the order pairs. So this is a very good question. Please note this. Please note this. And then once we ask this question, this is the first part. And second part maybe, now you find what is the number of elements in B. Number of elements in B you can find, count and write this. And that I should not write the answer. So please make sure you note it down. Okay, thank you so much. Now, one more question. Anyway, I told you this as homework, but I did it. But this is for you as a homework only. If A equal to n of A equal to m, then prove that or show that number of elements in P of A cross A. P of A cross A means power set of A cross A is 2 to the power m square. So this is absolutely a homework for you. Here, of course, I definitely tell you that it is important and this is a homework. Here, I should not tell anything about what power set is, and if you need any explanation, I'll do. Just you let me know if you know it, if you need it.
No, sir.
Okay. So now we are going to have some properties related to Cartesian product. Cartesian product, we have some properties, right? So these are very important properties. We'll prove few of them. For any three sets, please go on writing A, B, and C. For any three sets A, B, and C, we have number one, A union B cross C is equal to A cross C union A cross, sorry, B cross C. This is B. This is B. Anyone, just a minute, let me correct this. This is B cross C. Number two, right? If you have A cross B union C, is A cross B union A cross C. That means this is distributive, right? Over union. Similarly, if you want to take intersection, then also it will be distributive for intersection as well. Please note down this property. They seem to be very, very comfortable. It is okay, easy only, but on time sometimes we forget. So these are all the distributive property. Distributive property. Distributive property. Please make sure to understand this. If you have anything to ask, you can ask. Distributive properties, right? So this we'll be picking up some of the proofs. First, let me write some more. Then number five, if you have A union B taking Cartesian product with C union D, right? Then we'll be having all these possibly distributed, right? Because already we have got a distribution once. So it is A cross C union, right? A cross C union A cross D union B cross C union B cross D. Anyway, you might find that these are not very good or wordy So anyway, we have to prove this. Then the same thing we can do for intersection, right? So what we'll get here as A cross C, then intersection A cross D, then intersection B cross C, intersection B cross D. We get this. These are the two another important ones. Please continue writing. And actually, these are done applying these above distributive property only. So I do not want to give any name. Name is not there for this. I'll go to the next one if you have finished. Two more are there to small properties. Okay. So now next is difference. Suppose A minus B cross C. So it will be A cross C minus B cross C. And similarly, if minus is in the right side, difference of the set. So A cross B minus A cross C. So this is all about. This is all about. Please see that. Right at this moment, actually, what one very important point I missed in set, so that I'm going to tell you, so that it will be afterwards not a problem for. In set, we got something called symmetric difference. Symmetric difference. We told you, I explained you difference only, but symmetric difference is what, right? For two non-empty sets, A and B, A symmetric difference B, this is a symbol, a triangle is written, delta is written, that is union of A minus B and B minus A. This is called a symmetric difference. Right? This is called a symmetric difference. Now, quickly, if you want to see in the Venn diagram, that also you can see. Here, of course, I do not want to draw the what I say, what I mean, that universal set. So now, here, if I name this as A, this as B, right? Then this particular portion is A minus B, and this particular portion is B minus A, and that was A intersection B. So if you shade only this part, right? This part, this set you consider, and this set you consider together, union of this. This is known as the symmetric difference. So from the figure itself, you try to see once. So if somebody asks you, suppose somebody asks you the number of elements in A cross B. It can be directly written that it is A minus B, number of elements in A minus B, and number of elements in this. Or we can write it like this also. Number of elements in symmetric difference A, B is number of element in union minus number of element in intersection. So this would be little comfortable, right? So this is, and once you finish it, please give me a green signal so that I can go ahead. Okay, thank you. So now, last one more problem I'll be doing for Cartesian product. Perhaps this is question number 6. Let me check it. It is, what is the question number? I did, okay, anyway, forget about that. It is question number 6, perhaps. Anyway, if not, no problem. Just, I'm writing the question. if A and B are two sets such that n of A cross B is equal to 6. There are 6 elements, and A cross B contains contains 1 comma 2, 2 comma 1, and then 3 comma 2. Then find find number 1 set A, set B, and then A cross B, right? Number 2, represent A cross B graphically, right? Represent A cross B graphically. So this is the question what we are going to answer now, right? So the first thing is not a problem. Here I will not write a statement because already I have given you statement for the previous ones. So I'll start like this. This is belonging to A cross B. This is belonging to A cross B. So that will imply one belongs to A, two belongs to B. Then 2 comma 1 belongs to A cross B. This implies 2 belongs to A, 1 belongs to B. And then 3 comma 2 belongs to A cross B. So 3 belongs to A and 2 belongs to B. So from here you just first see what is the set 1. 1, 2, 3 it contains, and B is a set containing 2 comma 1. Now does it satisfy this condition? Product of this? Yes, it satisfies. So these are the accepted results. Now once you finish with this, you can immediately do what is A cross B. So I think my help is not needed, but still anyway, as I have picked up this problem, I'll finish with this. Then this is the first part. Second part we are going to do A cross B. So you just pick one element of A and relate with this other elements of set B. So this is here. Then 2 comma 1, 2 comma 2, then 3 comma 1, 3 comma 2. So you have finished with A cross B. Maybe they will ask you finding B cross A also, right? So you, sorry, this is not one only second part, this is one third part. So B cross A, once you find A cross B, you do not take tension to find the B cross A. Simply all the elements you reverse the places. No need to see even, this will be 1 comma 2. No need to see even the sets. It is 2 comma, it is 2 comma 2. So 2 comma 2 will be 2 comma 2 only. It is 1 comma 3, and then this is 2 comma 3. Right? So likewise you can do. Am I clear to you? Yes. Sort of. Okay. Now you see, if somebody talks about representation of this diagrammatically, graphically, so how you do? Actually, it is simple like the points. Simple like the points. That way you can represent. Like 1 comma 1. So you divide the unit. This is 1, this is 1. So 1 comma 1 will be here. Draw a point. Then 1 comma 2. A cross B I am drawing, right? 1 comma 2. 2 will be here, right? Then 2 comma 1. 2 comma 1. 2 will be here, right? Like this you go on plotting the points. Here let me plot it completely so that I can see 2 comma 2 will be here, and then 3 comma 1. 3 comma 1 will be here, and then 3 comma 2 will be here. So this is the graphical representation. This is the graphical representation of A cross B. This is A cross B. And now if you need to do B cross A, in the same if you do overlapping will be do there. So you should not do that. Now this is the way how we do the graphical representation. Now you can ask me one more question. I don't know whether it is coming or not. Supposing that instead of giving elements like 1 comma 2, somebody gives you like a cross a and b, and then b comma c, how will you plot it in the like representation? No issue. Here too we use the graphical concept what we had from earlier classes. No problem. If it is not 1, 2, 3, we will mark the unit as A, B, C here, A, B here. Then A comma A order pair will be here, right? Then B comma A will be here, like this. I do hope that you will be able to do this. So I give you 10 to 15 seconds. Please go through what I explained today so far. And if you have any questions to arise, you can easily arise, and then I'll go for the next one. Any kind of questions, if you have, you can arise.
Sir,
Yes.
in this, like if we have A, B, C, D as elements,
Hmm.
and we have to graphically represent them, then if we put ABCD on the y-axis as ABCD,
Hmm.
we have to follow the same order on the vertical axis too, right?
Yes, yes, that's you have to do. We consider that order only, that order we have to maintain. Otherwise, our all representations will be different. Like yours will be different, mine will be different. If you reverse the order, right?
Yes, sir.
Okay. So anyway, I have little left time left with me, so I'll give you glimpse for the next part, what we are going to study, that is called relation. So I'll be starting with that glimpses today, but I'll not go in detail today. Just I'll give the spark so that you can also use some idea. Relation, right? Relation is a very important word, right? Relation is a very important word in context or in reference with functions or maybe with pure maths. So what is a relation? In a simple sense, what we do, any subset, any subset of A cross B is called, any subset of A cross B is called a relation on A to the set B, right? Any subset, any subset. Now please recall that whatever number of subsets are there for a set, it was having these many numbers. If a set has n number of elements, then total number of subsets, that is number of element in power set, is 2 to the power n. So keeping in mind this, directly you can find number of relation on A to B will be simply 2 to the power n of A cross B, because it will have these many elements. So this will have these many subsets, and that gives you that totality of the number of subsets, right? So these many subsets, that means number of relations will be that many. So tomorrow, if somebody tells you that n of A has two elements and n of B has five elements, so how many relations from A to B are there? So it will be simply 2 to the power 2 into 5, that is 2 to the power 10, that is 102. So these many relations will be there from set A to set B, right? So now we'll be discussing what type of relations we have. This is the glimpses that we have started. Any subset of A cross B is called a relation, and for any two sets having certain number of elements in it is having that many relations. Did you note it?
Yes, sir.
Okay. So now what will happen? As I say that relation usually is denoted by R, right? So if R is a subset of A cross B, we called R is a relation on A to B. So this is what we have explained. Now you see, if this R is phi, because subset can be phi also here, because I did not restrict you that you cannot take phi or non-empty sets. Then R is called empty relation on A to B, or instead of empty relation, you can say it to be null relation on A to B, or you can say void relation on A to B. Choice will be yours, totally choice is yours. Which name you want. Basically, we use empty only, right? This is a word we use basically. Now, if R, in case it is equal to the complete set, then R is said to be universal relation, universal relation on A to B. That means A cross B completely we have to know. So these are the two important points definition we have to remember. This is one thing, right? Okay. Now the last point I'll discuss for today. Next day we'll discuss types of relations, etc. So as you can say, as R is a subset of B, so R must contain elements of the form, whatever form elements relate, ordered pairs, where A belongs to A and B belongs to B, right? R must contain this kind of elements only. That means R can be always written like what? R can be always written like this only, where A belongs to A and B belongs to B. But remember, if I do not write anything now, it will mean A cross B only. So here, and a condition. Condition means which will tell you how these are to be considered, right? And then if any element A comma B is belonging to R, then we write A is related to B. We read it what A is related to B. This is the way how we read it, or this is a symbol we write, or sometimes we can write it like this also. Uh, we may have different options, right? We can read it like write it like this also, but this notation is used more familiar way in functions, not in relations. Plus, we can use this, or we can write it like this also. Yes. Right. So these are the three symbols we use for saying that A comma B is in R, and then this we can read that A is related to B. Yeah, this is not capital, this is small b. So A is related to B. So this is what we have for today. I'll stop here. So before I stop here, I would definitely ask you if you have any queries, you can tell me, or else I'll sign out. Please
No,
give me
sir.
the. Okay, you don't have anything, so I'll sign out, and we'll see in the next day. So till then, whatever homeworks I have given you, do it. And class 11, the textbook, please do the first exercise of relation and function. ठीक है? Okay, Swarnav. So bye bye.